solve the equation, we have the absolute value of 6x minus 10 divided by 7, which is equal to 1. So let's go ahead and take a look at that. So here we can see that the absolute value is already isolated and it's equal to a constant. So that represents case number 1, because you can see that the absolute value of x is equal to a constant, and then we're going to use this equivalent form over here. So the second step of this problem is to have two equations. We have 6x minus 10 divided by 7, which is equal to negative 1, or 6x minus 10 over 7, which is equal to positive 1. You have to remove the absolute value bars because then you're applying the definition. So here's step 1 because it's in that form, and then you need to remove the absolute value bars. And now we're going to solve each equation. So if you take a look here, we're going to multiply both sides by the LCD. Well, the LCD is 7. So if we distribute the 7 to this term, we're left with 6x minus 10, because that 7 divided by that 7 is going to give us 1. And then we're going to distribute the 7 to the negative 1. So 7 times negative 1 is negative 7. Now we're going to do the same thing on this side. Again, here the LCD is 7. So we're going to multiply it to the first term. And again, that eliminates the denominator. So we have 6x minus 10. And then 7 times positive 1 is 7. And now we're going to solve for x. So we're going to add 10 to both sides. So we have 6x, which is equal to negative 7 plus 10, which is positive 3. Divide both sides by 6. And then x is going to equal the reduced fraction, which is 1/2. Or over here, we're going to add 10 to both sides. And we get 6x, which is equal to 7 plus 10, which is 17. Divide both sides by 6. And then x is going to equal 17 over 6. And therefore, here are our two solutions. We have 1/2 and then 17 over 6. Let's go ahead and plug those in to see if our answers are correct. So 1/2 and 17 over 6. So here we have 1 over 2, and then 17 over 6. Check our answer, and there is our result.